Welcome to The Explainer. We're going to tackle a huge question today, one that's right at the center of all the AI hype. Do these large language models we're all using actually think?
So, why does this even matter? Well, look at this number, $15.7 trillion. That's how much AI is expected to add to the global economy by 2030. It's not just a piece of tech, it's reshaping our world. So yeah, figuring out what's really going on under the hood, it's more important than ever.
And I mean, on the surface, it really looks like they do, right? You've seen it. They can write code, they can create incredible art, they can pass medical board exams. These are things that just a few years ago were strictly human territory. So to really get to the bottom of this, we've got to look past the magic show and see what's actually separating our minds from their processors. All right, let's get into it.
Okay, first things first, let's look at the machine side of this. What's an LLM really doing? Because at its heart, it's not about deep thoughts or philosophy, it's all about probability.
This right here totally changes the game and how you should think about LLMs. It's not thinking or knowing in the way we do. It's not looking up facts. It's basically a giant superpowered autocomplete. It's a pattern matching machine that's just making a very, very educated guess about what word is most likely to come next in a sentence.
So how does that guessing game actually work? Well, it's a four-step dance. First, it chops up your text into little pieces called tokens. Then it turns those tokens into numbers, because that's the only language computers really speak. Now, step 3 is the secret sauce, the attention mechanism. This is the bit that lets the model figure out which words are most important and how they relate to each other, even if they're on opposite ends of a paragraph. And finally, it makes its move, predicting the next token, then the next, always asking itself the same question. Based on the patterns so far, what's the most likely next piece of the puzzle?
Some researchers came up with this brilliant and kind of controversial term for them, stochastic parrots. Think about it. A parrot can mimic our words perfectly, right? But does it understand what it's saying? Nope. And that's the argument here. An LLM can sound incredibly human, stringing together perfectly coherent sentences, but there's no real understanding, no intent behind the words. It's just a very, very sophisticated mimic.
Okay, so that's the machine. Now, let's flip the coin and look at us. What's going on in our brains? Because this is where the gap between them and us gets, well, it gets huge.
See, our thinking is so much more than just crunching data. For starters, there's consciousness, the actual feeling of what it's like to be you, having a thought or an emotion. Then there's our grasp of cause and effect. We don't just see patterns, we understand why things happen. And maybe most importantly, we have this massive, unspoken library of common sense and intuition that guides pretty much everything we do. This slide just nails the difference. You and I know that fire causes burns. It's a physical reality. An LLM, it just knows that the word fire and the word burns show up together a lot in books and articles. It sees a statistical link, a correlation. We understand the why. That's a world of difference.
You know, philosophers have been wrestling with this stuff for a while. There's this famous thought experiment called the Chinese room. Picture this. You're in a locked room, and you don't speak a word of Chinese. People slide questions in Chinese under the door, but you have a giant rule book that tells you exactly which Chinese characters to send back out for every question you receive. From the outside, it looks like you're having a fluent conversation, but do you actually understand Chinese? Not at all. You're just following rules. And a lot of people argue that's exactly what an LLM is doing, perfectly manipulating symbols without any real understanding.
But, and this is a big but, it's not always that black and white. The newest models are starting to do things that make you go, They're stepping into this really fascinating gray area where prediction starts to look an awful lot like reasoning.
Yeah, I'm talking about what some top researchers are calling sparks of reasoning. We're seeing these models solve incredibly complex math problems, write working code from scratch, and even tackle sophisticated legal questions. These aren't just parlor tricks. These are tasks that we used to think required real, general intelligence. It's kind of forcing us to rethink what intelligence even means.
And one of the weirdest tricks that's unlocking this is something called chain of thought prompting. It's almost ridiculously simple. You just tell the model to think step by step before it gives an answer. And just like that, its ability to solve hard problems shoots way up. Now, is it actually reasoning, or is it just mimicking the pattern of reasoning? That's the million-dollar question right now. But either way, the results are seriously impressive. This all leads to a pretty wild, kind of mind-bending idea. Some folks are arguing that for a model to get truly, perfectly good at predicting text about our world, it might eventually have no choice but to start simulating how our world actually works. Like, to perfectly predict a story about a falling apple, maybe it has to build some kind of internal, unspoken model of gravity. It's a huge leap, but a fascinating thought.
Okay, but let's pump the brakes for a second. Despite all these amazing leaps, there are still some huge gaps. LLMs are terrible at long-term planning. They have zero real autonomy. And they're not grounded in the physical world at all. They've never felt the sun or kicked a ball. And you probably noticed this yourself. Have a long conversation with one and it'll forget what you said 5 minutes ago. They just don't have a stable, coherent memory like we do.
So, what's the bottom line here? Let's tie this all together and make it super clear.
This chart really lays it all out. Our brains are biological machines, honed by millions of years of evolution, for one main purpose: to understand the world so we can survive in it. LLMs, on the other hand, are silicon-based. They have a single mathematical goal: get better at guessing the next word. It's like we're both trying to get to a destination called intelligence, but we started in completely different places, and we're taking totally different roads. It's just, sometimes those roads happen to run parallel for a little while.
And that really leaves us with one last big thought to chew on. As these machines get better and better at mimicking us, at simulating thought, what does that really teach us? Maybe the biggest lesson here isn't about AI at all. Maybe by building these incredible artificial mirrors, we're finally getting a chance to look back at ourselves and understand for the first time what makes our own minds so special, so strange, and so uniquely human.